Hi there, it's Professor Monte. Let's talk about dividing and simplifying radical expressions. Okay, so if I have a fraction and it's all under the square root or cube root, whatever the radical is, I can actually break that up into separate radicals. So this would just become the square root of 25 over the square root of x squared. And remember, the square root of 25 is just 5. The square root of x squared, now we're assuming all of these variables happen to be positive numbers. The square root of x squared is just x. It's actually the absolute value of x if we're not making any conditions on x being positive. So it's either 5 over x or 5 over the absolute value of x if they're saying, hey, we don't know if the numbers were originally positive or negative. But a lot of times books simplify it by saying, hey, none of the variables were negative numbers to begin with. Okay, so that's the idea. We can break a radical into the radical of the top and the radical of the bottom. So similar here, but notice since they're all under the radical, we can reduce first if possible. Oh, 2 goes into 32 16 times. So this probably becomes the third root of 16a to the 6th over b to the 12th. And now I can break it up. So, and I'm not necessarily going to break it up this way. I'm going to think about it that way. So when I look at the 16, let's see, 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 twice. 16 is not a perfect cube, so I can't just pull it out. But remember from what we've done earlier, I've got a cube root. If I have a group of 3 of something, this is 2 cubed. So the cube root of 2 cubed is just 2. If I have a group of 3 of them, they come out just as a single 2. This one's left over. It has to stay inside the radical. And then with the a's, remember the easy way to do that. With the a's, I have 6, but it's the third root, so I just do 6 divided by 3. And 6 divided by 3 is 2. That means 2 of the a's come out. I have 2 groups of a to the third is what that means. And with the b, I do 12 divided by 3. So 4. So 4 of those come out. If I had any remainder, they'd stay in. So b to the 4th, that's my answer. Don't forget the third root since we had a third root. All right, and here's another one. Now this time it's a radical divided by a radical. But remember, if we can break it up into 2 separate ones, we can go backwards and make it a single fraction. So this is really the square root of 56xy to the 9th over 7x. And whether you're thinking that or you're just writing that, we can do it either way. But 7 goes in here 8 times, and those x's just cancel. So really what I'm down to is the square root of 8y to the 9th. Everything on the bottom canceled out, so there's no denominator there. It would be a 1, so we don't need to put it. But now 8's not a perfect square. You may see that as 4 times 2. The square root of 4 is 2, so it's 2 root 2. Or the way I like to do it is like I did over here. 2 goes into 8 4 times, 2 goes into 4 twice. Square root, I need 2 in a group. Well, I have 2 2's here, so 2 comes out. This one has to stay in. The y, again, I have 9, but it's the square root, so this time I divide by 2. Oh, 2 goes in there 4 times with a remainder of 1. So 2 come out, 1 remains in. So 4 come out, 1 remains in. And that's my answer. So when I'm dividing radicals, I can either make it a big single fraction reduce, or if I have a single fraction and it's easier to break it up into 2 single fractions and then do the radical of each one, numerator, and then radical denominator, it's going to depend, depending on what they give you and what you need to simplify.